Hello, good afternoon. Thanks everybody for coming. So my name's Kyle Rankin. I am the Chief Security Officer for a company called Purism. We make privacy and security focused laptops that run free software and soon a phone. But that's not what I'm here to talk about. But before I talk about this topic, I thought it would be sort of important. So I'm going to be covering some content in this talk that might upset some people. And so I would like to warn ahead of time, talk about some of the content that might be, some people may find upsetting. So if you are upset, you know ahead of time, you can leave ahead of time if it's going to upset you. So if you are a veteran of the Unix wars, I'm going to be talking about the Unix wars, not in great detail, but in some detail. So if you are a veteran of that war, and this might bring back some sort of post-traumatic stress of remembering what it was like back then, there will be depictions of some of the battles, just letting you know. Just wanted to put that out there. Okay, so all of you, now you know. If you develop proprietary software, just a heads up, I'm going to be saying negative things about proprietary software. So if you write free software on the side, but your day job is getting paid to write proprietary software, I might say something negative and it may upset you. Hopefully not, we're all friends here. If you use the cloud, because I wanted to make sure to include everyone. So if you use the cloud, I might say something in this talk that upsets you, offends you, makes you question or be concerned about your choices, or my choices too. So just putting all of that out there. So now that everyone's ready, we're all safe. If you feel uncomfortable, we can always leave and we can talk about it afterwards. Okay, so all that out of the way, I just wanted to start by talking about how we won. I mean, congratulations, everyone. I mean, if you were to talk to anyone about Linux right now in free software, what they would tell you is we won in all sorts of ways. We're super excited about how we've won. We tell people, if they will listen to us, about how much we've won and dominate the world now. So, for example, Linux and FOSDEM is everywhere. If you were to turn over a rock, and it's probably running Linux, or at least some free software somewhere, right? Everything's running Linux. So your Pocket probably is running Linux, or maybe it's not, but at least the dominant operating system right now, if you dig past all of the proprietary code and get right to the bottom of it, you'll find a little bit of Linux in there, and a little bit of free software. So, and that's in a lot of people's pockets, the majority of people's pockets in the world. In your home, right now, while you're here, when it's not DDoSing other people's networks, you have devices in your home that are running Linux, probably. Your refrigerator might even be running Linux. Your toaster, I mean, people in the olden days would joke about NetBSD running on everything, including a toaster, but I think a lot of the smart toasters these days are running Linux. So it's ubiquitous. In your company's code. So if you are a developer who's writing software and you're starting off from scratch with something, one of the first places you're going to look is a place like GitHub, and look for free software, libraries or frameworks or other things that you can use to incorporate, and then write your proprietary software with that. So it's very common. I mean, it's the main way that people do software development these days, is look for existing free software. And of course in the cloud. So, I mean, Linux and free software just completely dominated the cloud. If you look at cloud offerings today, the majority of the virtual machines that are running in the cloud are running some form of Linux. Usually the default is some kind of Linux. In addition to that, a lot of the services that they are offering, a lot of the way that people use the cloud is to run free software services of some kind. Or in some cases, their own applications that they launch. If they are not free software, they are at least often built using free software frameworks. So we've just completely dominated the cloud. I mean, it's really, when you ask most people about this, they either talk about we won because of your Pocket or we won because of the cloud. But I mean, so we've won with the cloud so much that Microsoft now loves Linux. Not only do they love Linux, but they have professed their love for Linux in public on numerous occasions, some more romantic than others. But in any case, they love Linux now. This is something that would have been unthinkable for a long time ago, but it was largely a result of how Linux thoroughly dominated the cloud and caused Microsoft to look into their cloud strategy. And if you're trying to sell a lot of companies into moving into your cloud platform, which you view as the future of your company, and they say, okay, great, and they say, well, yeah, this cloud platform is great. We can run all of your Windows servers that you currently have in the cloud on our cloud. And they say, okay, cool, but what about the other 90% of our servers? How is your Linux story? And so they had to dramatically rethink how they approach the cloud, and now are huge advocates for free software and huge advocates for Linux. In fact, they love it. So if you're going to point to another reason why we won, that would be a pretty good reason, because a lot of us who were originally, who've been around in this community for a long time, that was like the enemy, you know, like there was this sense like forums would just, the $$ stuff that I'm sure some of you probably still do, like a lot of that stuff is going on forever. Okay, so, but if we won, then who lost? You know, if there's winners and losers, then who lost? Well, I kind of already talked about it. If you were to ask somebody in the community that's been around for a while, who lost if Linux won, then they would probably say Microsoft. But honestly, I don't like, really, we're mostly just talking about Windows Server here because, like I said, it's sort of like there's not a lot of people in here probably that would say, man, IBM, you know, they'd be really mad about Big Blue from back in the 80s, right? Because they started spray painting tux graffiti in the 90s on sidewalks and stuff, or maybe it's 2000. Anyway, everyone's like, well, yeah, they're a big advocate for Linux now, and everyone is not concerned about anything in the past. And so a lot of people still sort of dwell on Microsoft, but the downside of doing this, and I would caution you against doing this too much, is if we continue to look in the rearview mirror about the battles we had in the 90s and the early aughts, in the meantime, we've allowed all of these other giants to sort of come in and take their place, and we don't really notice because we're like, yeah, but remember that time when Microsoft like embedded Internet Explorer? Wasn't that, you know, that was awful, you know? So I would suggest not to dwell too much on that. Who else lost? Sun. So Linux's success was largely at the expense of Sun in their dominance in server rooms. You could argue that in addition to Microsoft Windows Server not getting as much of a footprint in the data center, Linux also supplanted the existing Unixes that were in the data center, and Sun took the brunt of that, ultimately being acquired by Oracle. But we're going to get more into that. Research in motion. A long time ago, everyone sort of thinks that if you're winning today and someone's dominant today, that it will always be that way, and no one can ever, you know, kind of fall from their pedestal. But everyone was using a phone from this company, Research in Motion, a long time ago. That was the platform. Everyone from celebrities to dignitaries, all the way down to your average person in an office, were using Research in Motion phones. But their operating system and their company was really affected by Linux's dominance on the cell phone market, and in particular providing this nice platform for creating applications on phones. And proprietary Unix, often, in many cases, lost because of this. In some cases, the companies went out of business. In other cases, they're still around, but in some cases, proprietary Unix will always be around, probably. There's still administrators running AIX systems in a number of places, but largely Linux's success was at the expense of proprietary Linux or Unix. Also, embedded OSs, you know, all of those Internet of Things devices that we talked about before that are DDoSing everyone all the time and never being updated. That's because they're running Linux. They're not running a proprietary embedded OS anymore, usually. I mean, these companies are still around, but on the average, if you're going to make a new toaster that is smart and sends you a tweet whenever your toast is done, it's probably going to be running some sort of Linux embedded OS with some sort of proprietary application on top of it. Okay, so we won, but did we really win, though? Maybe we won at some point, but I get this sense that if we did win, if you would argue that we did win, then we're starting to lose some of that ground that we gained when we did win that battle. So what do I mean? So when I was a kid and had my first computer, so to date myself, it had floppy disks. And the way that you would get software is, in my case, I would go down to the grocery store, and they had this little cart that had different shareware floppy disks that you could buy. And that's when my first exposure to games like Commander Keen and Wolfenstein before it was 3D, and things like that. And the idea behind the software was you would get a floppy disk, and it was essentially a demo. And the idea was you would share this floppy disk with your friends who would install it, and for free what you would get is a demo or like the first level of a game. And then if you wanted the rest of the game, then you would pay money and you would get what we would now call the pro version of the game that would unlock all of the rest of the levels. Well, we have the same thing today. Basically, most of the applications on our smartphones are some form of shareware one way or the other. It's either free and the money is being made by advertising or otherwise capturing and selling your data, or it's free and it's sort of like a demo where half of the features are disabled, right? And so, and if you want everything enabled, then you buy the pro version. And in all of these cases, the code's not available. It's all, while there are free software applications on mobile devices for sure, the great majority of them are some form of shareware. Your company's code. So I mentioned before how great it was that your company is using all of this free software when it's writing its internal applications, that it then closes, right? Companies, well, of course there's exceptions, and hopefully there's a lot of exceptions in this audience. But on the average, if you were to go to a startup and who's really excited about all of these frameworks that are out there that allow them just to get bootstrapped and running an application, they would then take that application using all of those free software frameworks, and their company's code would then be locked behind the walls of the company and not be released. So there's open core. So this is a phenomenon where it sort of dovetails a lot with startups. So the idea behind open core is that you have some section of the code base that is free software, and then surrounding it in some way, either via plugins or an enterprise version, there is a proprietary version of it where the source code is not released, and that's usually how the company makes their money. Often, open core companies will start. So when you're doing a startup, usually you get a very small amount of money to sort of seed the startup, and you can't afford a lot of developers. And so a lot of times in open core companies, what will happen is you will create a free software project and put it out there, and that way you can get community interest. And it's almost like, sort of demos and build some excitement about the product you're building. Get a lot of free development. And then what's most important when you're doing a software startup is to have some sort of prototype that works, that would be suitable for enterprise. So you can then provide that demo to venture capitalists and get your next round of funding. So usually what happens then is you get this community going, you get that first round demo, you then can demonstrate that to venture capitalists who will give you, $1 million or $2 million or something, or however much. And then you can hire some of those open core developers who are in the community, the best ones, bring them in, and then they can start working on your proprietary enterprise product while occasionally backporting things. Eventually, if you're successful, you have this nice successful company that's starting to build revenue, and then you can hire a lot of developers, you get more investment. And then ultimately what ends up happening is the free software thing often becomes sort of a demo. It's considered often a toy, where you wouldn't really use the free software for enterprises because it's kind of a toy, like proprietary software is what you need for the enterprise. And so ultimately you have this weird separation where features get added to the enterprise version, and the open source version or the free software version, the community tries to backport them, which is weird because the company is supposed to be maintaining both, but then the community has to backport these enterprise features. In some cases, things like encryption. I would like my network to be encrypted. Well, you must be an enterprise if you care about that, right? So the cloud. So we won the cloud, right? There are more Linux VMs and free software in the cloud than anything else. But where is the software that runs the cloud? We nominally think, well, yeah, it's probably all running Linux, and there's VMs that are running Linux. But the way that most people use the cloud, and I'm going to get into this more later, is not very open. You wouldn't really know that it's running free software or that it's Linux. You generally interact with it through a series of APIs that are based on some service that you don't have the source to, and you're talking to it via that way. So in many ways, especially when you look at the cloud, we are returning to the time before the rise of Linux and FOSS. There's a lot of this ground that we gained that we're losing for a number of different reasons that I'll get into. So in essence, it's the same sort of thing where we have a brand new play We have the same play, but we have brand new actors. So we have new tech giants, but the battle is largely the same. It's still sort of this notion of, is free software a toy, or is it legitimately should be used for enterprise, and is it good, suitable for production? All of us would probably say, yeah, well, of course it is. But some of that's being called into question, and if you listen to a lot of people's marketing who are selling proprietary software, they have that sentiment where basically, well, yeah, if you want to dabble, if you're a hobbyist, you go over here to the free software side. But if you're serious, if you're a business and you need to depend upon software, then it has to be locked up in proprietary. That's the only thing you can trust. So part of the premise of this talk is to say, well, it seems like we're starting to rehash a battle. What can we apply from the last time we had a battle like this and won to the situation today? And so the bulk of this talk is going to be talking about that. So let's talk about the Unix wars a little bit. I told you I would. So there's a period of time where the network was the computer. This was, before, let's talk about before the dot-com boom, because I'm going to get into that. So the network was the computer. So that means we had these end-user workstations that were not very powerful, and in many different ways. They lacked resources in a number of different ways. And so what we would do is move storage, because we didn't have huge hard drives where we could store all kinds of things on our workstations. We didn't have a lot of storage, so we would move storage, computation, and even desktop environments all on the network. And so you would have this. This is after just a normal, like a dumb terminal that had just text. We're talking like graphical desktops would be on the network and come over the network because it was the local workstation may not have enough resources to handle it. This is a time where the transition from mainframes into large Unix servers. So instead of like one standalone gigantic mainframe, you would start having smaller but still cheaper but still relatively expensive servers running Unix. There was a number of main hardware vendors, and each of them had their own flavor of proprietary Unix that would run. So Sun had Solaris, IBM had AIX, HP had HPUX, and then Silicon Graphics had IRIX. And each of them would bundle that Unix with their operating system. It wasn't necessarily something that was charged for, but it was their operating system that would come with the hardware you bought. The thing is, these operating systems were proprietary. We couldn't see the code, but they did have open APIs. And they had a POSIX standard, which meant that you could write applications for one and be relatively assured that if you followed the standard, your application would run well on another Unix. This was incredibly powerful for developers because as you can imagine, you want this kind of compatibility. What ultimately ended up happening, though, was people would then take the existing proprietary Unix, especially as this became more dominant and some of the user space became a little stagnant. People would put GNU tools on top. So the GNU project started rewriting a lot of these user space tools on the command line and a compiler and having it all be free software. And so one of the first things you would do as an administrator would be you would install all of these GNU tools. In fact, a lot of the first free software companies that became successful out of providing support for free software on proprietary platforms, not on Linux. The other thing to note is each of these companies had incredibly amazing engineering teams, very, very smart people, really doing cutting-edge work in a lot of different fields. It's not like all of them were making incredible advances in computing at the time. Some of the engineers from each of these companies moved on to do incredibly great things after they left that particular company. The main focus was on hardware features and redundancy. So what I mean by that is you would see things like hot swappable CPUs and RAM in one gigantic machine, and then the software that could handle doing that without losing any workload on the machine. There was also this sort of assumption, well, and I'm sure in some cases people did blends, that there's this assumption that if you were a Sun shop, you were a Sun shop, and you only had Sun hardware. If you're an IBM shop, you only had hardware from one vendor, and that's where you would get everything. So let's contrast that with the cloud wars. In the cloud wars, the network is the computer. There's this notion that we have these small devices that don't really have enough resources to do everything themselves, and so they reach out to the cloud for resources. So things like file storage, because there's not a lot of storage often on mobile devices, computation, You will run all of that in the cloud, and even desktops. A lot of people will have remote desktops, and there's a couple of companies that provide security solutions where they will take a desktop and sort of sandbox it in a cloud environment, and you can use it, and if it gets infected, you can wipe it and restart. But it's all on the network. So in this case, the transition, instead of from mainframes to large servers, is from large servers that were local that turned into really small but remote virtual machines. So in this case, the players we're talking about Amazon with AWS, Google with GCP, Microsoft with Azure, and Oracle, and there's a number of other providers that all want a piece of this cloud pie because they see that it's, in many cases, the future of providing profitable services. So again, these services are all proprietary, but they do publish their APIs. Their APIs aren't compatible with each other, unlike with Unix, where you at least had a standard to code against. Generally, with these providers, their APIs, while open, are also proprietary, and there's not a lot of collaboration between making them agree with each other. And like with Unix, you would take this cloud environment with proprietary APIs, and then you would put FOSS tools on top of it. It could be Linux VMs, it could be your FOSS application of some kind, like MySQL or something, some sort of Rails application, or your entire environment. Again, all of these companies hire amazing, incredibly smart people to build these platforms, and they have all kinds of advanced features. Very smart people making these things, and every year you hear about all of these new features, all of these new things that make your life easier, all of these new innovations on these platforms. In this case, the focus is more on software features than really hardware features. I mean, hardware features are saying, well, we added a new 7x large whatever. They add maybe a faster machine, but that's not where the innovation is. The innovation is on all of the software services and the redundancy. There's also the assumption that you get everything from a single vendor. These vendors are not operating thinking, well, yeah, you're going to get a little bit from me and a little bit from Azure and a little bit from GCP or whatever. They all assume you're going to use them for everything. Okay, so let's go back in time again. So now we're still in the middle of the Unix wars, but let's scoot ahead to the dot-com boom. So the dot-com boom was this era where if you took a business model and then put it on the internet, you could get a lot of venture capital. And so a lot of people did this. They would say, well, what if we took a grocery store and we put it on the internet? Or what if we took a bookstore and we put it on the internet? And everyone's like, that's a stupid idea. Or they said, that's a genius idea. I don't even know how to evaluate you because it's on the internet. The rules don't apply anymore. So if you knew that if you took a business and put it on the internet, that you could make millions and millions and billions of dollars, then wouldn't you start to spawn new websites that were running some interesting business? And so there's this huge push for new websites all over the place. Everybody needs a website now, where before they didn't know what the World Wide Web was. Now everybody needs a website. Your company needs a website. Everyone's trying to buy up all the .com domains because they now are instantly super valuable. Lots of servers, lots and lots of servers to make this work, which means huge data center growth. If you're in Silicon Valley during the time, they were building up, taking properties and building in data centers. They couldn't build them fast enough. There were often waiting lists to rack servers. They were just filling up constantly all the way through the bust. But it was an amazing time for data center growth in the area. And Sun Solaris dominates. Now, I'm sure there are fans of other platforms that would say, well, maybe, I don't know, like we didn't use that or whatever. But a lot of people's data centers were running Sun and Solaris machines during the beginning of the .com boom. So normally you would have hardware maybe running NSCA or Netscape Web Server, depending on, Netcraft would say it would be NSCA mostly, but one of the other, you would probably run some sort of C or Java middleware that would do some sort of application logic. And then all of this would be housed in a really big, can never go down Oracle database. The one database. If you have environments now where there's the one server that can't go down, it's probably your Oracle database from this era. So most of the software development for these .coms were, for these web applications, were done on proprietary workstations. At the time, the proprietary workstations were probably running Windows or Solaris. So there's this sort of famous quote that Sun put out as part of their marketing saying, we are the dot in .com, to sort of demonstrate their dominance with .com servers. They were actually referring to the fact that they were a major DNS server at the time. The dot is, it's weird because the dot's not even in .com, it's the missing dot, the invisible dot that you don't see at the end, because they were a root name server. DNS nerds, yeah, all right. I'm not a tattoo guy, but if I could tattoo DNS, I would anyway, that's personal. Okay, so let's get ahead to the next .com boom, where what we did was we took a business model and we put it in the cloud. Which you might say, well, that sounds an awful lot like putting something on the internet. And I say, yeah, that's exactly the same. It is exactly the same thing. But this time it's a massive push for new web services, because what was happening was everyone was starting to use this computer in their pocket as one of their primary computing devices. And everyone saw this huge business opportunity in creating some sort of application that they could put in this computer in your pocket that would talk to this web service and somehow make your life easier. And all of these businesses started moving all of their platforms to cloud providers to provide the computation and the heavy lifting you needed because you were running on this sort of underpowered computer in your pocket. Lots of VMs. Lots and lots and lots of VMs. You needed lots of VMs. For one, they were cheap and they were small and they were sort of underpowered unless you spent a lot of money on them. And the other thing was they were notoriously unreliable. But it's your fault when they went down, because they told you, we're unreliable, it's not our fault, things are going to crash all the time, the network's going to disconnect sometimes. It's really just an unstable environment, that's your fault. So everyone started learning how to build very redundant systems, which meant lots of VMs. And VMs spread out all over the place. And then you would do that, and then there would be a massive outage somewhere, and somehow your service would go down anyway, and it would be your fault, and then you would find out there's a bigger basket. You thought your eggs were in 3 baskets, but they were actually just in 1 basket that was bigger. So this spawned a huge growth in cloud infrastructure companies. Amazon had the head start here, and so they massively expanded, became sort of the default. But there were a lot of other platforms, both just pure cloud infrastructure where you would get VMs, and other ones that would sort of contain an application and run an application for you, that started like growing, and now there's a lot of consolidation in the industry, but there's a lot of these companies that were spawning from this. And in this case, we're talking about a migration off of traditional data centers. So a lot of people were also saying, well, it's about time to buy new servers, but boy, they're expensive. And the network engineers and system in there running them are pretty expensive too. What if we put it all in the cloud? We wouldn't need nearly as big of a team. We wouldn't have to have this big capital expense that we have to make every 3 to 5 years. And so a lot of companies started making this migration. Like I said, AWS dominated. It still dominates because it had this great head start, and everyone just sort of de facto started moving to it. Although, again, there's a lot of contenders now that are trying to win the crown in the cloud wars. But what you normally would see is some sort of Linux VM. It was running either Apache or Nginx. The middleware was a blend of a bunch of different languages, probably Ruby, Python, Java, JavaScript usually. And then on the back end, you would have like a MySQL or a Postgres server, or maybe a NoSQL database. And that's sort of like the traditional stack early on, at least before it became more service-oriented. Again, software development during the dot-com boom, 2.0 was on proprietary workstations, this time mostly on MacBooks, and then on Windows machines as well. This also saw a lot of common FOSS services. So what would happen is a lot of people would say, we like this NoSQL database. And they're like, everyone's using this NoSQL database, and they're all creating their own NoSQL database, putting it in a VM. And the cloud provider started looking at the most popular services that people were using and say, what if we hosted that for them? And they would just go through us. We'll make it a little bit cheaper than it would cost to set it up themselves. And they could just use our custom server, our proprietary service, instead of setting it up themselves. And so they started doing this and then putting sort of an API in front of it to manage it. And you started seeing this more and more and more, where if a service is popular, it's only a matter of time before it becomes a new custom service. All right, let's go back in time again. So we're back at the middle of the dot-com boom, and Linux is dismissed as a toy by Unixes. If you were to talk to any of them about, well, yeah, I was thinking about maybe setting up a Linux server. I've been hearing good things about it. All of these major Unix companies would say, it's a toy. Maybe it's good for a hobbyist, but if you want to do real work, you need a real production quality operating system. You can't handle real load with this. But then we have the release of the Apache web server, and it's hard to underscore how important the Apache web server was for Linux and its success in the data center. Because what it did, it had this great feature called virtual hosts. And what that meant was you could host multiple websites on one web server, where if you're buying a bunch of expensive individual servers and you can only run one website on them, that's kind of a pain. You can run multiples, that's great. It was cross-platform, so you could run Linux and Apache on commodity hardware. You didn't have to buy expensive servers. You could buy a random Intel server and run a website on it. You also had LAMP stacks, and this is something that replaced a traditional sort of Sun and Oracle blend that people would do, and this is a combination of Linux and Apache. MySQL as the database, and Perl originally as this middleware. And so there was this service called, this standard called CGI, the Common Gateway Interface, that would allow you to write snippets of code that you would then put on a server that was running CGI. If you hit a URL, it would execute that code, take some inputs from the web query, do some work, and then output a result, output HTML to the browser. So ISPs started doing this thing where they would allow you to upload snippets of code. Ultimately, PHP became more popular for this, but you would upload snippets of Perl or PHP code to an ISP's web server because they wanted to offer web services. And by doing that, what they would let you do is you would execute it on the fly. If someone hit this, it was amazing, mind-blowing. If you would hit this endpoint, it would execute this code and give you this return. There's this other problem that cropped up where people were buying these incredibly redundant but single Sun servers to run Oracle. And they're very expensive because they could hot swap CPUs, they could hot swap RAM, they had all of these amazing features. But they were expensive, and it turns out some people said, well, what if I just put MySQL on 3 servers that were about $5,000 because they're Intel, and if one goes, I can't hot swap CPUs, but I can take a server out. And so people started doing this, and this started dramatically eating into profits. And it starts the trend that ultimately replaces proprietary Linux, in my opinion, with proprietary Unix with Linux. And so Linux FOSS then wins the Linux wars. So let's scoot ahead there's this new technology that's just came out that's referred to as serverless. And what serverless is if you were to look at a CGI script, which is a snippet of code that you could run somewhere, upload, and if you hit an endpoint, it would execute. Serverless is that, only it's proprietary. Because back in CGI days, you could take a CGI script and put it on your ISP. You could put it in your own server running Apache with a CGI module, or you could put it on a competitor. It didn't really matter. But with the modern approach to CGI is to have sort of a custom language, a custom API that only runs on one cloud provider. But the same sort of story otherwise. The interesting thing about serverless is that you have this further separation between the developer and the actual FOSS services and Linux that are there, because you're not really interacting with an icky Linux server that's running FOSS services. You're just sort of dealing with an API. The ultimate goal is honestly just working with APIs, not to have to deal with servers or not have to deal with services, just sort of write APIs. This also conveniently makes it harder to leave the platform, because if your entire code base isn't even transferable because it's using all of these little snippets of code that use a custom API, it's that much more difficult to leave. Is there Linux or FOSS behind these serverless services? I don't know. I haven't seen the code, so it's possible, but I haven't seen the code, so who knows? So all that to say, this goes back to sort of the premise of this talk, which is the cloud is the largest proprietary, any cloud infrastructure is the largest proprietary OS on the planet. So AWS, Google Cloud, a lot of people don't think of them that way because they think, yeah, but it's split up in a bunch of these little VMs. And like, well, what about mainframes? Didn't mainframes have a bunch of these little isolated processes, but they had a single operating system? And the cloud, any cloud infrastructure largely operates as one single unified but proprietary operating system. Where's the code? If you wanted to run an instance of AWS or GCP or Azure at home, could you do that? Could you download and build their code and then run a smaller instance of it yourself? No, you couldn't. But we don't really think of it that way, largely because the APIs are open, right? We think, well, the APIs are exposed, so that's all that really matters because they document their, well, of course they're going to document their APIs, otherwise they're not very useful. But a lot of people mistake documented APIs with openness. So usually, like today's devs, if you were to have a developer or a sysadmin work on the cloud today as it's intended to be used, and they didn't have a lot of background, they would get very minimal exposure to Linux and FOSS. Generally speaking, in my prediction in the next 5 or 10 years, the job description for both will become the same, which is basically I'm writing API glue. But I might be writing it for different services, but the jobs will sort of converge into someone who's basically writing API glue code to use the cloud. The other interesting thing is a lot of people just sort of accept vendor lock-in these days. It's odd, because if I say, there was a point in time where vendor lock-in was like a bad word, and you said that like, ooh, yeah, I don't want that. And now a lot of people are saying, well, what's the big deal with vendor lock-in? Of course, you would be foolish to switch to another platform, because my cloud's too big to fail. It will never have any flaws. There's never been any history of any cloud having an outage. And my provider will always stay in business, you know? But here's another question. Okay, fine, maybe it's too big to fail, but what happens if your cloud wins? Or what happens if a cloud that you're not using wins and yours loses? What do you think the cloud provider would do then? How do you think their innovation in all of this rapid development would go, and their pricing structure would go, if they won and they were the dominant player? Or put it another way, if they won, would protocols on the internet really need to stay open? If all of the websites on the internet, mostly, and if all the websites were running on one cloud provider, would they need to communicate with each other using open standards? Couldn't you foresee a day where someone says, well, yeah, but all of this HTTP stuff is pretty slow. We're going to replace it with a custom service, so if you're inside our cloud, you get all of these benefits of our speed. If you're outside the cloud, of course, you're slow and awful. But if you're inside the cloud, you get all of this stuff. It's not that hard to conceive of. The other thing is, if all of these services replaced Linux VMs with something proprietary, would anyone notice? I mean, those of us who go to the cloud and spawn a Linux VM would notice, but people using the cloud as it's intended to be used would have no idea. You could just switch out my NoSQL service with one that's running proprietary code instead of a standard free software version, and no one would notice, and a lot of people wouldn't care. So what do we do, like us? What do we do about this? Well, the first thing is to look back into why did Linux and FOSS win to begin with? So I would argue that Sun's dominance early on led to some complacency and some arrogance. The whole thing of, well, Linux is just a toy, it will never do anything. And that also led them to sort of dismiss some of the advances it was making. And innovation started slowing, not so much in the hardware, but in particular for the user interface. So things like you would commonly hear people talk about, I would get my workstation open, I log into my Sun server, I type a command, oh, I made a mistake, backspace. Oh, why does the backspace work? And this is like a small little trolley comment, except that there's this notion that, well, yeah, the backspace doesn't work. You're not using a Sun workstation. If you use a Sun workstation with a Sun keyboard, it would work fine. All you have to do is add this STY command, and it's totally fine. But what it points to is more of this arrogance that went along with, well, we're never going to update tar to have modern command line arguments, which nowadays, did you know that you don't even have to specify like what compression algorithm to use when you're uncompressing something? It just sort of figures it out. It's sort of amazing. But they didn't do that. Like back then, it was just straight up vanilla tar, vanilla everything. That's why people installed GNU tools to begin with, because the free software world was innovating faster. Here's the thing. There were more FOSS engineers than Sun engineers. A lot of people like to think, well, yeah, but they're super smart engineers, they're the best, and that may be, but there's also only so many of them that are working on software. And when you compare it to the world of free software developers, there's a dramatic difference. Linux and free software innovations outpaced the rest of the innovations that everyone was making. That's why everyone shifted to it. In addition, because the openness of everything, the cross-platform compatibility, it turned hardware into this commodity. You could run this platform on anything. Ultimately, it even made Suns look into doing x86 and eventually even opening their software in Solaris. But by then, it was too late. Okay, but that doesn't tell us what we do, right? So what do we do? Well, one is you should recognize proprietary code when you see it, or I should say when you don't see it. There's a lot of times where we just have this, we don't even really think about it. A lot of people just focus on, is the API open? But ask yourself, when you're using a service, okay, well, that's cool. If I wanted to run it myself, could I download the code? Can I at least inspect the code, even if I don't know how to run it myself, to see what it's doing? A lot of times the answer is no. I would say we should resist proprietary services. Vendors make it very easy to only use them for everything. That's the whole point. Vendors have always done this. I mean, vendor lock-in has existed forever. I started a series on this at Linux Journal to talk about some of the old stories of vendor lock-in because I'm honestly not sure that a lot of people are familiar with the problems with vendor lock-in. So that's the next thing, ideally, everyone could do who's been around and understands what can happen when a vendor has tight control over your entire environment, is tell your stories. Share with people some of the problems with that. Here's the thing is the fact that we as a community are open and we focus on compatibility and we share our source code is our advantage. And we don't always realize that as an advantage, but it allows us to do certain things that proprietary companies would never do. They couldn't do because it would impact their business too much to free some of their software. It allows us to we can take advantage of that and allows us to do things that they can't. Please share your innovations. If you're developing software that solves a real problem, please release it under a free license. I know it's very tempting to take it and then use it as the start of your new startup. Very tempting to do that, but please consider instead sharing that innovation with everyone else so that we can all together get further along than we could otherwise. And finally, I sort of want to pose this question to everyone. So one of the big things that drove Linux's success in the data center was this LAMP stack, this notion that there was this combination of all free software services on a free software operating system that could run on commodity hardware that was not just, it was easy to set up, and it was powerful, and it was suitable for production loads. What's the equivalent of that today? What's the equivalent thing that would cause everyone to question their use of the proprietary services that they're using today, that they're relying on today? Is there one? Could one be created? Or is it that if someone were smart enough to come up with something like LAMP today, they would be too tempted by the desire to close it all up and turn it into a startup and we wouldn't see it? Hopefully the answer is some of us are already thinking about this problem and are working on some solutions to that, which you can talk to me about that later. But hopefully some of you are also thinking about that. What the next things that we can work on to reestablish free software as the de facto way that we do things on the internet, because it was that way at one point. We all grew up, some of us grew up appreciating the benefits, but it's not a given. And if we don't do something, it won't always be there. Thank you.